All right, where can I start? Where can I get practice questions? First place, in your packet, page 31. All right, on packet page 31, you will see 8 questions. Some of them are some algebra questions. Some of them are indirect proofs that you can practice from. But you have 8 questions in your packet, page 31. Also, at the top of page 31, you have textbook questions to try. All right, so again, packet page 31, 8 questions, and then you have textbook questions that I'm recommending at the top there. All those answers are in the back of your packet. Okay, all those answers are on the last couple pages of your packet if you want to find out if you're right or wrong. This morning, I also put together a couple other practice, and this is on Classroom. All right, if you just want to focus on your screen real quick, just let me show you what I did. Up on Classroom, under Unit 5. Okay, under Unit 5, you will see Unit 5 Test Extra Practice. There's a folder there that contains some files for you guys if you would like to practice. They're separated by topic. Separated by topic. We'll get there in a second. Come on now. There we go. So I got a partitions worksheet. I got points of concurrency worksheet. Circumcenter, incenter, orthocenter, centroid. I got points of concurrency on the graph. So if I graph a triangle, can you find the circumcenter? Can you find the orthocenter? All right. And then finally, triangle inequality theorems. 2 sides has to be greater than the third side. Biggest side across from biggest angle. All right, so all divided up evenly. I'm just going to warn you guys, please listen carefully. Please listen carefully. A couple of these have answer keys, a couple of them don't. Sometimes I just don't have the time to put all these together with the answer keys. All right, I'm more concerned with getting you guys the questions than getting you guys in the answer keys as well. Like I know partitions and triangle inequality theorems have answer keys. I don't think the points of concurrency don't, but you can certainly email me and see if you're right or wrong. All right, so that's another place you guys can go to get extra help, or extra questions, I should say. All right, so plenty. I always make sure I hook you guys up with enough practice for any unit test we're going to take. That's always my goal going in, that you have no excuses that you didn't have enough to practice. So that's where you guys can go to get any extra practice. Let's look at the topics right now. I'm not going to read them off to you. You guys can look at them right now. You can screenshot it. You can write it down. But what I need from you is ask questions. Hey, could you clarify what you mean by this? Can you tell me, can you give me an example of this, etc. All right, I'll tell you all I can about the test if you ask it. All right, if not, I'm not going to say any more, and we'll just go on to some practice problems.
As far as the 3 triangle inequality ones,
yep.
I can remember the one about an exterior angle is going to be greater than either 2 remote interior angles. What are the other 2?
Yep. Let's just go over all 3 right now. All right. Don't want to do that. All right. So the first one, which is the one was just stated, which is an exterior angle is greater than either remote interior angle. Okay, that's the first inequality theorem we discussed. An exterior angle is greater than either remote interior angle. Just to show you real quick, I don't have this is going to come out of your textbook. I just don't have the time for you guys to log on to your textbook and look at it yourself. So if you want to just look on your screen right now, here's what I'm talking about. All right, these are part of the suggested textbook questions I put on top of page 31. Number 20 says, all right, take a look at angles 1, 5, and 6 in this diagram. 1, 5, and 6. Which one is the greatest of the 3? And this is where I would apply that theorem. If you take a look at angles 1, 5, and 6. They're part of this triangle right here, where angle 1 is an exterior angle. So without a doubt, based on that theorem, I already know angle 1's bigger than 6. Because 1's the exterior and 6 is the remote interior. I also know 1's got to be bigger than 5. Why? Because take a look. Angle 5 is a part of this angle right here I'm doing in red, which is a remote interior to 1. So 5 is part of that red angle. It's definitely got to be less than 1. So out of those 3 choices, based on the theorem I just went over there, it's got to be number 1. All right, so just an example of how I apply that theorem. All good? All right, second inequality theorem we should be aware of. In a triangle, sum of 2 sides greater than the third. Okay? In a triangle, sum of 2 sides is greater than the third. I believe I put a multiple choice question down where I gave you, I think, 4 different triangles with side lengths, and I said, based on their side lengths, which one could be a triangle? So one of those 4 will fit into this theorem. There will be another question similar to this one right here, where I give you 6 and 7. Can you please list as an inequality, could you please list the possible values of the third side? As an inequality. So you write your compound inequality, make sure you put the less than symbols with X in the middle. Anybody remember, want to chime in now? How can I find what X has to be in between without listing out every single possibility?
You can add and then subtract the 2 other sides.
There you go. So if I do 7 minus 6, it's got to be in between 1. And if I add 7 and 6, it's got to be less than 13. So somewhere between 1 and 13. Everybody all right there? Also, I could do this tomorrow. Still give me possible values of X, possible values of X, but that third side's going to be X minus 2. Of X minus 2. So if you guys do this, if you still give me between 1 and 13, that's wrong. Those aren't possible values of X. Those are possible values of X minus 2, the third side. All right, 1 and 13 wouldn't be possible values. It would be possible values of X minus 2. I'm looking for possible values of just X, So in this case, we get rid of the negative 2 by adding 2 on both sides. So if you wanted possible values of just X, it would be between 3 and 15. Okay, so just a heads up on that. All right, if I ask for possible values of the third side versus possible values of X, totally different there. We okay there? And the third and final one, the third and final theorem. And after I write this down, we're going to go in your packet and do an example. In a triangle, biggest side is across from the biggest angle. Or you could substitute in smaller if you wanted to. Biggest side is across from biggest angle. Okay? So we're going to go to one right now. We actually did not get to it the day we did this in our notes, and it's very important that we discuss this. So can everyone go to page 21 in your packet? Page 21. We did not get to that last question. And it's an important one. All All right, everyone sees question 2 there on page 21. In the entire diagram, which segment is the longest? All right, and I know many of you, based on that theorem, are just going to say, just find the largest angle, look across, that's the longest side, but that is not the case, and I will show you why. Before we even start talking about what's the longest side, it would be nice to know all the angle measurements, right? So I could compare. So if you got, if you got your calc, if you need it, grab it, find those 2 missing angles, and we'll talk. Because I can't start comparing shortest, longest until I know all the angle measurements. So I got 60 degrees here, hopefully you're finding, and hopefully 57 degrees here. All right, now if you look at the diagram, some of you just say, 70 is the biggest angle, BC, biggest side, I'm done. You just found the biggest side in triangle BCD. I'm asking for the entire diagram. See the difference, kids? See the difference there, guys? You just found the biggest side in triangle BCD, but is it really the biggest side in the entire diagram? How do we find out? We're going to compare the sides in triangle ABD to the sides in triangle BCD, and watch what happens here. So we're going to, since we're trying to find the longest side, I'm just going to rank them from longest to shortest here. And you don't need to show me this much work. Just making sure I'm detailed. Longest to shortest. Rank them for me. All right, rank them for me. All right, here we go. And again, it's a review day, guys. I don't have the time to go bounce back and forth from the numbers. I'm hoping you're paying attention at home because this is going to be important to you tomorrow. All right, anybody want to just go right now? Give me the sides. Longest to shortest in triangle ABD. Longest to shortest. Which one's the longest side in ABD?
BD.
BD. I'm just looking for total participation here without having me go to the numbers. BD. Next.
Yeah.
BA. And what's the shortest side? AD. All right, good job, everyone. Now let's go to triangle BCD. What's the longest side in triangle BCD? BC. Who's got next here? BC. What else here? CD. And the shortest side must be BD, right? All right, let's look at what we have right now. Can we figure out which one is the longest side? Well, BC is the longest side in BCD, and BD is the longest side in ABD. So it's got to be one of these two. All right? It comes down to the longest side is going to be one of those two because they're the biggest side in both triangles. Does anybody see a problem with one of those being the longest side based on the rest of our rankings? Look at our rankings. Does anybody see any problem with one of those sides being the longest?
BD.
Yeah, BD, everyone. I got a problem. Look, you put BD right here in triangle BCD, meaning there's 2 sides bigger than BD. So how can BD be the longest side in the entire thing if you wrote that there's 2 sides bigger than it? So my longest side has to be BC. Has to be. There's no way it could be BD because you just wrote down there are 2 sides longer than BD. Everyone all right there? Because I am going to take it to an honors level right now. Questions? Go ahead.
Never mind, I'll wait till after you're done.
No, go. Just do it now. Go.
So let's say it asked you to order something and something showed up twice, and like the same side showed up twice. Will you just pick the second highest then?
I don't know. I don't think I understand your question, Sophia.
Let's say it asks you in this one to list them from like shortest to longest.
Which I'm about to do right now.
All right.
All right. So yes, that was my honors level question now is rank them from longest to shortest now, everyone. Can we rank them every side now? Can we rank every side from longest to shortest now in the entire diagram. Because honestly, that's what I'm going to ask you to do tomorrow. All right, I'm going to ask you to rank all the sides tomorrow. I don't know what direction, shortest to longest, longest to shortest, but I am going to ask you to rank them tomorrow. So we already know number one, longest side, BC. Anybody think they can find the second longest side based on what we've written up there? Is it BD now? Or do I have to go to another one? Is the next one going to be BD, or is there something bigger than BD? Look at what you wrote down. Is it BD or something bigger than BD on here?
I think it's BA.
BA? Okay, but hey, the way you listed it, you told me BA was shorter than BD. Right? That's what these two right here mean. BA is shorter than BD, so BA can't be the next one. Is it BD? All right, yeah, it's not BD. Because, hey, look, again, guys, I can't stress this enough. Look right here. There's BD. There's something above it that you said was bigger than BD. It's CD. So CD comes next. Because you said CD was longer than BD. Now where am I at finally? Now I'm at BD. All right, I got two left. Which one's bigger, BA or AD? This is why we write it down in this order. Which one was bigger, BA or AD? BA. So that means the smallest one out of all these was AD.
I'm a little confused. Why is it CD instead of BA? Because they both have got one that's greater than them.
Okay, but here's the thing though. If you're going to put BA, right? If you're going to put BA, we still haven't even put down BD yet. And hey, take a look at these two. If I just said, look at those two sides, you're going to tell me BD is the longer one because that's what you wrote. BD is bigger than BA, right? BD greater than BA based on what we just wrote down in triangle ABD, right? But look over in triangle BCD. Didn't you tell me that CD was bigger than BD? So CD's got to be bigger than BA. It doesn't mean guys. It doesn't matter what you put second, what you put third. All right, you got to look at both triangles. In this triangle BCD, BD was the smallest side. There are two sides bigger than BD, CD and BC. So before you even write down BD, you have to write down BC and CD because they are definitely bigger than BD. Other questions? I won't do it with you because you guys need the practice on your own, but I'm just letting you know. And please don't do it while I'm still reviewing. There's another one in your packet on page 31, number 3, where you order it now from shortest to longest. So there is practice there if you need it. All right, I won't go over it right now, but you guys can practice that one on your own and the answer's in the back. All right? So there are the 3 inequality theorems. I know that took a while, but it's a pretty big topic. So, all right, let's go back to the test topics. Others you want me to go over in a little bit more detail, explain.
What's the for partition again? Like the steps you do?
For a partition? Did I hear that correctly? For a partition? Okay. Let's see. How should because I know there's not any in your packet because it's up on the classroom page. I might as well just go to the classroom page and see what I put. There we go. Partitions. Here we go. Let me just take a question. There we go. I'll just take number 5 here, copy it, and paste it onto my notes. Nothing's going to get tricky. I'm going to give you 2 points. Here's the ratio. Find the point in between them. All right? Nothing tricky, guys. Nothing tricky. All right. So paste. All right. Here you go. Reviewing partitions again. So my A point is -8, -2. B is 16.6. Find a point that breaks it up into a ratio of 3 to 5. Which means to me you have to break AB, the segment AB, into 8 congruent parts to do this. All right, 8 congruent parts. I saw on your quiz a lot of people have different ways of doing this. I always start with the x coordinate and I say, all right, how long on the x coordinate is AB? You're going from -8 to 16. So if you go from -8 to 16, on the x-axis, you are going 24 units. You don't just combine them. I saw some of you on your quiz, you just do -8 plus 16 and you got 8. No. It's the distance on the x-axis between -8 and 16. All right, I just don't add them together. All right, you got to find the actual distance between them, which is 24 units. Take that 24 units, divide it up into 8 equal parts. Meaning, every time you divide it up into 8 parts, you're going to go 3 units every time. So 3 units. Go another 3 units. There's another point. Go another 3 units. There's another point. But the question is, and this is where some of you got stuck on the quiz, how many times do I need to go 3 units? Well, it all depends on what is that first number in the ratio, which is 3. So I got to go 3 units 3 times for 9 total units. All right, 9 total units. Keep going, keep going. That doesn't say you're going to end up at 9. All that says is you're going to go 9 units from the starting point, which is -8. So from -8, if you go 9 units, you're left at 1 on the x-axis. And I don't think you guys believed me when we did partitions, but that x-coordinate that you end up at, 1, has to be in between the 2 original ones, -8 and 16. It has to be. If you get 18, 20, -10, you know you did it wrong. It's got to be in between the 2 original x-coordinates. Same thing for the y-coordinates. All right, now I'm going from -2 to 6. Oh boy, what's that, 8 units? Again, just don't combine them. Figure out how many units apart they are. 8 units divided up into 8 equal parts, which now instead of going 3 units on the x-axis, I'm going only 1 unit every time. How many times? 3 times. I go the same amount. You never use the second number. All right? You don't use the second number in the ratio, just the first, because you're going from A to B. If you want to use the second number, go from B to A, but I'm not getting into that. So now this is going to say, now you're going 3 total units. Go that, guys, some of you guys forgot to go this extra step. You just left 3 as your y coordinate. No. You're going from -2, 3 units up. So you end up at 1. So yes, my partition point here would be 1, 1. Whew. Nothing different tomorrow. Go ahead.
One last question. Inscribing and circumscribing, I don't have to spend a lot.
Yep.
I might circumscribing is like a triangle.
Here you go, right here. And again, I'm bringing this up because it will be vocabulary. I put in a multiple choice question, and I didn't want you to freak out because you have not seen this since your day 1 notes. All right, this came up in your day 1 notes. If I inscribe a circle, that means it's inside the triangle. It hits all 3 sides of the triangle if I inscribe a circle. So that's inscribe right here. We're like in the circle is inside. Versus if I do a circumscribed circle, the circle is on the outside. It touches all three vertices. All right, so it's talking about where the circle is as far as in regards to the triangle. All right, for inscribed, the circle's inside the triangle. For circumscribed, the circle is outside the triangle. All right, and I just wanted you guys to be aware of that. I didn't want you to just all of a sudden be confused. You're reading this multiple choice question, and those two vocabulary terms come up.
What was the fill in the blank using terms for a word from a word bank?
Yep, so there's going to be 6 questions, 12 words in the word bank. So obviously you won't use them all. This won't be on there, but an example of one I would put on there would be the perpendicular bisectors of a triangle intersect at a point called the blank. Circumcenter. All right, so you would have to fill in the correct word. The segment that joins a vertice and the opposite side's midpoint in a triangle is called a blank, median. Okay, that's what I'm talking about, fill in the blanks. 6 questions like that, but 12 words. So yes, you got to know that chart again. Where does that, angle bisectors, where do they intersect? Altitudes, where do they intersect? Centroid, that's the intersection of all three medians. All right, keep going. I am soaking every second out of class today.
How many partition questions are there?
1.
With the orthocenter,
Yep.
if it's an obtuse triangle, is the orthocenter on the outside?
Yep, here you go. Ready? Acute triangle. If I have an acute triangle, all 3 altitudes, the orthocenter will be located somewhere inside. I do not expect you to find exactly where inside, but know that it's inside. Obtuse triangle. Know that the altitudes will all intersect outside. I will not have you find the exact point, but you should be aware that the orthocenter is somewhere on the outside. Right triangle. That's a different ball game there. Right triangle. Please remember, and some of you got this incorrect on your quiz, altitudes. The legs of a right triangle. The legs of a right triangle are also altitudes. They are perpendicular to the opposite side. Meaning, where's the orthocenter on a right triangle? Where those 2 legs meet. Could I actually have you find that point? You're darn right I could. All right? Find exactly where the orthocenter is on a right triangle I give you. Absolutely, I could ask where that point is.
Do you think you could show us what a point of concurrency on a graph kind of question would look like?
Okay, I can tell you, I'm going to do circumcenter. Where's the circumcenter on the graph? I would highly recommend looking on your quiz. We did that. I don't know. I want to say it was question 2. But don't quote me on that. All right, look at your quiz. We found the circumcenter. Also, look at packet, page 5. Packet, page 5. You guys did it on a right triangle. Where's the circumcenter on a right triangle? All right, I would be prepared for both. All right, whether it's a right triangle or it's not a right triangle, and I ask you to find the circumcenter.
I remember the question I had when I was going over the quiz.
Yep.
Was that I couldn't, I knew how to find the bisector of the, I knew how to find the midpoint of the line.
Yep.
Each individual line and draw a bisector there.
Yep.
I didn't know how I was supposed to make it perpendicular.
Okay, so if you had it, let's see if I can fit this in here. I think it was probably something similar to this triangle here. You find the midpoint using the midpoint formula. So let's say D is the midpoint, right? All right, now that takes care of the bisector part. Now you got to take care of the perpendicular part. So you need to find the slope of the side you're drawing it through. So the slope of AB. So let's say it was +1. The slope of AB came out to be +1. You did rise over run. You did y2 minus y1 over x2 minus x1, and you found it was +1. The slope of your perpendicular bisector is going to be the negative reciprocal. So the negative reciprocal of 1 is -1. And I know I don't have this on a graph, but that would tell me from point D, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And then I grab my straight edge, and that would be your perpendicular bisector. Right here.
Right, because I was thinking of something like, I was confused because I was like, we don't have a compass to do this with.
Nope, so you got to do slopes. You find the slope of the side of the triangle, do the negative reciprocal, and go from the midpoint. All right? And I think that's going to be it for me. Guys, I'm here after school to go over more and more questions that you have. All right? Please make use of it. Be prepared for tomorrow. Don't worry about what's going to happen. What's that? Yep, 2:15 to 3. Bring your questions. Bring anything you got for me. Anything's fair game after school. Have a good day, guys.
Can you put a packet in the for you to say?
You got it, Hannah.
Thank you.
Yep. It'll be there by the end of the day, okay?